Hey pre-calculus students, here we are in section 6.5. We're going to be talking about translations of sine and cosine functions. Okay, so I am going to give an equation that's slightly different than the text, but it's totally relatable. I do this not to add to confusion, but to clarify a few things. So when we talk about these equations, sine and cosine, the sine and cosine equation, I'm going to think of them in this way, okay? And I'll talk about them in this way. I think there's like a C, but the text uses a C divided by K, and I'll explain why that's happening. So I want to talk about what each of these letters in this form is going to do to our sine and cosine function. And so there's a lot of things you already know. So you already know, guys, that A refers to the amplitude, and that amplitude is going to give that vertical stretch of your function. It's going to give you how tall or how high your sinusoidal or curve will go. Then we talked a little bit about B, and I've talked about B previously. I think we used K in the text, but I'm going to call it B now. B is the coefficient of the angle, right? So whatever the coefficient of that angle is, you want to factor that out of the expression that you're finding the sine or cosine of. So notice that I've got B out here outside of parentheses, and so B, if you remember, is going to give me information about the period, okay? So I'm going to use B to find information about the period because I remember that the period is going to equal 2 pi divided by that B term. So I know that I can get the period using the B term there. And probably the next easiest thing to discuss, because it's something that you're going to remember from other functions, right, guys? You remember that when we add or subtract something to the entire function, what we get in situations like that is a vertical shift, okay? So we will have a vertical shift. Now let's think about this in terms of what we're dealing with. So you know we're dealing with a sine or a cosine function. Let me rock a sine function real quick. We're dealing with a sine function, and no matter what the amplitude is of this sine function, if I take this sine function, whatever it is, and I add a number, what's going to happen is the zero line will shift up. Think about it. So you know that no matter what the amplitude is or the period is, however fast it's going or however high up it's going, the central line, the median line, I've been talking about that, the midline is 0, right? But when we add something to it, we shift the entire graph up. We shift it all up. And that vertical shift is going to change the midline, the middle of the line that travels through the middle of that sinusoidal curve. So D is a vertical shift up or down. Okay, so we've got a vertical shift, but we also have a change in the midline. So Y equals D would be the midline. I hope that makes sense, okay? So I'm going to highlight all of that in green because they're all related to one another. The next thing I want to talk about is C. Now, C is very specific. My C and the textbook C are different. And again, my goal is not to confuse, but to clarify. They don't write it this way. They will have, let me think. I'm just doing this just so you know what's happening. They have like blah, 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 A times the sine of, I think, K theta minus C plus H or something like that, which is totally fine. A is going to do the same as A does. K is going to do the same thing as B does. H is going to do the same thing as D does, but this C is different because remember I told you it has to sit like this in order for this to make sense. We'd actually have to factor out the K, and so the textbook has K looking like this, or has this C term looking like this, C over K. And I find that cumbersome, confusing, and a little bit unnecessary. So I've seen it done this way in previous textbooks, probably the way I was taught. And so that's why I'm choosing to automatically, when we write down an equation in what I'm going to refer to as like a sinusoidal standard form, we want to factor out of this expression whatever that coefficient of the theta term is. You'll see it come up later. All right, so with that in mind, this C term is now going to be a horizontal shift. All right, so it's going to be able to give us a horizontal shift left or right in our equation. So this was the vertical shift. This is a horizontal shift, just like we're used to. Just like we're used to when we're dealing with any function, we always get a horizontal shift when we deal with stuff that is being added or subtracted to the x term. All right. And so that phase shift comes from our horizontal and vertical shift. Our midline comes from the vertical shift specifically. We've got this period that we've talked about. So the two new things here that we're talking about really are this C and D. Okay, that's the new stuff. And then this idea of compound functions is basically like, okay, now that we know this function, we can join a bunch of functions together. So instead of just having y is equal to 2 times the sine of theta, we could also say plus 2x and see what that brings us. And so the suggestion in the text is for us to investigate these by making a table of values where you would not only find the sine of, oh, I shouldn't put x, I should put theta here. So it's just one variable, but you guys get what I'm saying. What we would do is we would plug in values, we do an XY table, and we would kind of graph it. I think I'm going to play around a little bit with Desmos with these particular examples, but with these up here, when we're kind of trying to figure out this equation, I want you to graph these by hand. The compound functions where you've got a trigonometric function, and this would be a linear function because it's akin to 2x. Those guys, we're going to try them out by hand, but we're going to largely graph those with Desmos. So with that in mind, let's get started with some examples. Okay, so in this example, we're asked to state the phase shift for each function and then find the function. So we've got two parts. Part A is the sine of theta plus pi. And so let me be clear. Phase shift refers to a horizontal shift. Is going to be that horizontal shift, and that's that C point of the C value. So we're trying to figure out what is the shift that's going to happen. And so when we add the pi, it's going to have a shift to the left pi. And so let me write down our formula again that we talked about earlier. Okay, so hopefully that's kind of clear. So now what we need to figure out is how to graph that. So I like to have, and down here in red, let me write down exactly what the equation is. Y is equal to sine of x. I like to have the typical equation there so I can kind of see what the adjustment would be. And so what it looks like is we're going to have a phase shift of pi in the left direction. So whatever is happening here is going to be slid back here, and whatever's happening here is going to be slid back here. So you guys can see, let's change the color so we can, let me highlight this in orange, and therefore I will draw it in orange as well, what the phase shift would look like. So I'm sliding everything back. So what's happening here is happening here. So all of the 0 points are going to be the same, but the highs and lows are going to switch. You guys see that? So I'm going to bring everything back 1 pi movement, and this orange graph is what we get as a result. Okay. And if you like this technique of grabbing the sine graph so you can kind of compare, you can do this as well when you are preparing for your homework or something like that. You can clip something, do a little bit of a clip of a picture of something in Desmos, which is where I got mine. So this is going to be y is equal to the sine of theta plus pi. Notice there is no a value other than 1, so that doesn't change from the original function. The b value or beta value, as I've written it here, is going to be 1 as well, so the period doesn't change. There is no vertical shift, which we're going to refer to as the midline, so this should be sufficient for this graph. Let's look at part B. So part B is one of those examples that I would definitely rewrite, because you know how we talked about our graph having the form A cosine B. And I know I'm writing it over and you're like, I got it, but just trust me, it's just helpful to see it again and again so you can understand. Notice that when I rewrite it, I want to factor out whatever the coefficient of the degree is, the angle measure rather. So I've got y is equal to cosine of 2 times the quantity of theta minus pi over 4. I changed that to pi over 4 because I know 2 times pi over 4, if I distributed it through, would give me pi over 2. And so now I can see what's happening. What's my phase shift going to be? My phase shift is going to be pi over 4. Since it's minus, it's going to be in the positive direction or to the right. And I see that my period will actually change. So I'm going to go get a graph of the typical cosine function, and then I'm going to graph over top of that. So we can see here's y equals cosine theta. We're going to be comparing it to this graph. Couple things are happening we need to be aware of. First thing we need to be aware of is that there's no change in the amplitude. There's no vertical shift. So that's cool. The only thing we're dealing with is being concerned about the period, and we're going to be concerned about this horizontal shift or this phase shift. So let's first consider what the period's happening. What's happening with the period? The period is equal to 2 pi divided by that cosine, the coefficient of the angle theta rather, divided by 2. So the period's going to be pi. So if I'm thinking about this, everything is going to be happening much quicker. So I'm going to go. Sorry for the sound effects, but in my mind sometimes they help. So this is what my graph is going to look like. So that's everything happening in a shorter amount of time. So instead of the whole cycle happening in 2 pi, it's going to happen in 1 pi. Fine. Notice I dotted it because that's not the final thing that's going to happen. But after I have this kind of a change, then I've got to consider this phase shift of everything happening in a sense at pi over 4. What would have happened at 0 is now going to happen at pi over 4. So everything moving up at pi over 4, a quarter of a pi of the way. So I took a moment just to write out the pi over 4 markings so we can see the shift easier. And so we saw our graph did that, but now this is going to happen here. This is going to happen here. You guys see it. We're going to come down to the bottom here. We're going to move up to 0 here. We'll move up to 1 here. And so everything is just moved over a bit. And so our graph is going to, it's going to come down here like this. And it should be doing this. We should be moving in that direction like that. And this is our final graph. You guys see that? All right, maybe I should make that a little bit bolder for us. Okay, I tried to make that a little bit darker, and I realized I had gone down too low when I was doing my little dotted scatter line, but hopefully that makes sense and you can see that. All right, let's go ahead and look at example 2, which introduces the idea of a vertical shift. So we're going to state the vertical shift and the equation of the midline for the function, then we're going to graph the function. So if we take a look, let me get a black pen here and one that is not so thick. If we take a look, we can see that we have a couple things going on. We got a lot going on here. So one, we have an amplitude of 2. We have a vertical shift of -5. And so that means that hopefully you can see that the vertical shift of -5 is going to impact our midline. So our midline is going to be at y equals -5. All right, and so since it's cosine, I'm going to grab a typical cosine function or a regular y equals cosine of theta function. And as you know, hopefully this will stay put. As you know, these functions can be really, really helpful to graph. So we're going to start by just confirming that yes, this is y equals cosine of theta. And this 2 tells me that the amplitude I'm dealing with is going to go up 2 and down 2. But the midline being -5, y equals -5, means that I've got to, let me identify, I'm going to draw this graph in green. So I'm going to circle it in green and come down here and draw the midline in green as well. So that's going to help me out. So that's the midline where my graph comes. So really what I would be thinking is that typically this line would move down here if that was the only change in the function, but that's not. We also have, in addition to a midline change, we have an amplitude change, which means that if the graph had stayed at 0, we would go up 2 and down 2, but since it's down here, we're going to go up 2 from the midline and down 2 from the midline, and that would capture the entire range of our function. And after that, everything else is going to be the same. So in true cosine fashion, we start up at the top of our at the top of our, or the highest value that we can be in, and then we go down and back up. And the only thing happening is this stretch and this stretch and this shift. And so you notice that our zero values, I know this isn't the prettiest graph, y'all, but you notice that our zero values are going to stay pretty much the same. Our max and min values are going to stay pretty much the same. So I really can just follow the shape of the original function, and that should be pretty good for me. And so this is the graph we get. I'm sure yours would be better, but you get where we're going. All right. So now we have the whole kit and caboodle. Everything is happening. I want us to just go back to the function that we talked about, or the way we related the equation earlier. We said that y is equal to a, the amplitude of cosine, times b. Look at me. I'm factoring out the coefficient of theta. You know, we're about to do that again here, plus d. And so in this equation, if I write it in that form, I get y is equal to 4 times the cosine. What is the coefficient of theta? 1/2. I'm factoring out 1/2, and so we got to think about this. When I factor out 1/2 here, this just becomes theta, but when I factor out 1/2 here, when I divide this by 1/2, I actually get 2 pi. Y'all with me? I hope you are. Plus or minus 6. And so couple things we know. We can tell that we are going to have a amplitude of 4. We're going to be dealing with the cosine function. We're going to have a period that's going to change. Can you tell me automatically what the period's going to be? Just by looking at this 1/2 value of b. Hopefully you remember that the period is equal to 2 pi divided by b, or 2 pi in this case divided by 1/2. Therefore the period is going to be 4 pi. So the whole thing is going to be stretched out, right? And we can tell that when we get a fraction next to our angle. So it's going to be stretched out, and then there's going to be a phase shift of 2 pi, and we're going to be shifting downward. So a lot is going to be happening with this function. Let's go ahead and bring in a standard y cosine of x function. Okay, so I've got my graph, and I'm going to talk about the 4 things that are important to us. 1 is the amplitude, 2 is the midline, and I would say probably in reverse order. Midline is probably the most important thing as we are just trying to orient ourselves with the graph. Let's say we're going to graph this in, I don't know what color this time. Let's say this gorgeous purple. We're going to graph it in purple. We're going to do the midline over here. That's going to be a highlighter. That's not what we want. Okay. So we're going to graph this right here by starting off with our midline, which is at negative 6. So that kind of orients me on the XY axis, which is helpful. The next thing I want to do is kind of consider my amplitude. So that's how high up I go from the midline to how low I go, how much below I go to the midline. So I'm going to be coming all the way down to negative 10 and going all the way up to negative 1. And so that kind of just helps me track my graph. The next thing I want to do is consider the period. And by the time I do those 2 things, I want to draw a graph, and then I want to save my phase shift for last. So what I did is I looked for the midline first. I did that number 1. The second thing, I marked off what my amplitude would be just to get an idea. The next thing I'm going to do is investigate my period and how it figures into this whole graph. And then finally, I'm going to do my phase shift. I think that's a reasonable way to do this. So my period has this graph stretching out all the way to 4 pi. So one period is going to be up to 4 pi, which is here, whereas usually one period is up to 2 pi. So really everything is happening in a very exaggerated, stretched out form. So my max value is going to be at 0, and at 4 pi my min value is going to be at 2 pi. And so I'm going to do this. Boom. Swip up through here and back up. Let's do it again. Try to get another one. And I'm going to try to lighten this graph because this is not the actual graph that I'm going to be using, because I still have to do a phase shift. But let me just kind of complete that there. Oh, autocorrect. Let's try it again. Get this down here. You guys get what I'm trying to do. Okay, good. So now that we have that done, I will probably do our final graph in an even darker purple, if that's even possible, or maybe I'll use a thicker line. So what I'll do here is now consider, since I've done 1, 2, and 3 and done a sketch, I think my phase shift will happen next. My phase shift is going to have 2 pi to the left. So whatever is happening here is going to be moved back 2 pi. And so what's happening here will be here. What's happening here will be here. And so you guys can see what's happening. You can see that basically this is going to be a very similar shift to one that we did earlier. We're going to have this happening like that, coming up, coming around, like this over here, coming up, coming around, and like this. And I'll make this one a little bit bolder if I can by rocking a highlighter on it, so you know that this is the graph. This is my final graph. All right, took a little bit of time, but sometimes it's just helpful to kind of figure out what you're doing, but hopefully that made sense. Let's go ahead and look at the next example. I'm going to let this be our final example for today. We're skipping example 4, which had more of an application. We're going to do number 5. Write an equation of the sine function with amplitude 4, period pi, phase shift negative pi over 8, and vertical shift 6. Okay, whole lot going on, but I think we can handle it. So we know it's a sine function. So we've got y is equal to something times the sine of some number times theta minus some number. Okay, we're going to do it in the way that we've been talking about it, plus some number here. And so we remember that this number is going to be related to the amplitude. It will be the amplitude, some form of it, a negative or positive form of the amplitude. This number is going to be b, and it's going to be related to the period. All right, so we can use the period to find that. This number is going to be the phase shift, and this number would be the midline or the vertical shift. Okay, so not shift, but shift. Let's get it right, darling. Okay, good. So I think it looks like, well, you guys get I'm trying to write shift here. I don't know what's happening, but whatever, such is life. Since the amplitude is 4, we are going to place a 4 right there in as that coefficient. Now, they gave us very little information. It could be negative 4, to be quite honest, but we're going to assume that it's positive 4 unless other details imply that. We are told that the period is pi, and so let's remember, we know that b, or the period, is equal to 2 pi divided by b. So similarly, b, or sometimes referred to as beta depending on the text, is equal to 2 pi divided by the period. And since the period in this case is pi, then we know b in this case to be 2. So then we can put that there. And now we are given that the phase shift was a negative pi over 8. And if it's negative pi over 8, we plug it in right here, and that would end up giving me theta plus pi over 8. But let me put that negative pi over 8 in there just as we were given it, and then we'll figure it out later. And then finally, a vertical shift of 6 means plus 6. And so to tidy this up just a bit, our final answer will look like this. Y is equal to 4 times the sine of, now if we write it the way the textbook has it, they would distribute that 2 through. So 2 theta minus, or plus rather, because a negative never gives us a negative, and negative gives us a plus, pi over 4, and that will be plus 6. So this is one way, or have it as a plus 8. I prefer this form, but I think this is what the textbook was looking for us to get. And that'll be it for our examples. Listen, I hope this is making sense. I know that we're trudging through a lot of information. Some of this takes practice. Use Desmos to help you as you work through some of these practices. And I look forward to talking to you guys soon. Take care.